So practice 7.9, questions number 1. In the diagram on the right, points A, B, C, and D are the vertices of a parallelogram ABCD. M is the intersection point of diagonals AC and BD. Finds A, the coordinates of C and M. In a parallelogram, the diagonals bisect each other. This means the point M here divide the line segment AC into two equal halves. So the length AM is equal to the length MC. And the M also divide the length BD into two equal halves. So DM is equal to MB. So this means the point M is the midpoint for the AC and BD. So here I'm going to find the coordinate M first. So here you can refer to the formula of the divisor of line segment. And the ratio dm to mb is equal to 1 to 1. To find the coordinate of midpoint, we just need to sum the x coordinate and divide by the total ratio, as anything multiplied by 1 is the same as the number itself. So here for the coordinate m, the x coordinate will be -1 plus 5, then divide by 1 plus 1, which is the total ratio. And for the y coordinate, it will be 6 plus 2 divided by 1 plus 1. So this is equal to 4 over 2 and 8 over 2. So simplify this, you're going to get 2, 4. So now we can proceed to find the coordinate C, as we know the coordinate M. So let's say the coordinate C here is xy. Again, the ratio AM to MC is equal to 1 to 1. So here when we sum up the x coordinates for the point C and A, which is the x plus -3, and divide with the total ratio 1 plus 1, this will give us the x coordinate of the point M, which is the number 2. So here x minus 3, this is equal to 2 times 2, which is 4. So x is equal to 4 plus 3, which is equal to 7. And when we sum up the y coordinate for the point C and A, which is y plus 0, and divide with the total ratio, this will give us the y coordinates of the point M, which is 4. So here y is equal to 4 times 2, which is 8. Therefore, the coordinate C will be 7, 8. Questions B. Finds the ratio of the area of triangle ABM to the area of parallelogram ABCD. As we know the coordinate of each point, then we can calculate the area using the shoelace formula. So here I'm going to arrange the coordinates of triangle ABM anti-clockwise. So here the area is equal to 1 over 2. So I'm going to start with the coordinates M. So 2, 4, followed by -3, 0, 5, 2, and end with the first coordinates again. So this is equal to 1 over 2, and we're going to sum all of the products in this direction. So bracket 2 times 0 is 0, -3 times 2, this is going to be -6, and 5 times 4, this is going to be +20. Then minus the sum of all products in these directions. So bracket 4 times -3, this is -12, 0 times 5, this one is 0, and 2 times 2, this one is +4. So this is equal to 1 over 2. So the first bracket will give us the answer of 14. Then minus the second bracket, the answer will be -8. So here 14 plus 8, we're going to get 22. And 1 over 2 times 22, the answer is 11. And for area ABCD, we're going to use the coordinates anti-clockwise. So the area is equal to 1 over 2. We're going to start with the coordinates A. So -3, 0, followed by the coordinate B, 5, 2, and C, 7, 8, and D, -1, 6, and end with the first coordinate. So this is equal to 1 over 2, and we're going to sum of all products in this direction. So bracket, -3 times 2, we're going to get -6, 5 times 8, positive 40, 7 times 6, this one is positive 42, and -1 times 0, this one going to be 0. And minus with the sum of all products in these directions. So bracket, 0 times 5, this one going to be 0, 2 times 7, positive 14, 8 times -1, -8, and 6 times -3, this is going to be -18. So this is equal to 1 over 2. So the answer in the first bracket is 76, then minus with the answer in the second bracket is going to give us -12. So 1 over 2 times, so 76 plus 12, we're going to get 88. And 1 over 2 times 88, this is equal to 44. So the ratio of triangle ABM to the area of the parallelogram ABCD will be 11 to 44. So this one we can simplify it by dividing every one with 11. So we're going to get 1 to 4. Questions number 2. The straight lines y equal to 8 minus 2x intersect the straight lines y equal to k, x-axis and y-axis as a point P, Q, and R respectively. Given the area of triangle OPR is 12 units square, with O as the origin, finds A, the smallest value of k. So here we're going to transfer the informations into the Cartesian plan so we can see it clearly. For the straight line y equal to 8 minus 2x, the number 8 here will be the y-intercept, and the -2 here will be the gradient. And to find the x-intercept of these straight lines, we are going to substitute the y-coordinate with 0. So 0 equal to 8 minus 2x. And we're going to move the -2x to the left-hand side. So positive 2x is equal to 8. Then x is equal to 4. That will be our x-intercept. So the intersection points at the x here, x-axis here, we're going to label this as the Q. And at the y-axis, we're going to label this as the R. As for the straight lines y equal to k, this will be a horizontal straight line. So there are two possible positions for the straight lines y equal to k. The first one will be the straight line y equal to k is above the points R. Then the intersection point between the two straight lines, which is the P here, will be on the left-hand sides of the y-axis. The other positions of y equal to k will be lower than the point R. Then the intersection point, which is the P here, will be on the right-hand side of the y-axis. So here the question asking you to find the smallest value of k. Then we're going to refer to the second possible positions of the y equal to k, as this one will give us a smallest value of k. So here I'm going to show you two solutions for this questions A. So method number 1, as we already confirmed that when the y equal to k is lower than the point R, it's going to give us the smallest value of k. Then the area of the OPR will be on the right hand side of the y-axis. And here the coordinate y will be the k. So to find the area of the triangle OPR, which is equal to 12, we can use the formula 1 over 2 times base times height. So this is equal to 12. And based on the diagram, from the origin to the point R will be the base, which is equal to 8 units. Then here will be the height of this triangle. So when 1 over 2 times 8 times the height, this is equal to 12. So 1 over 2 times 8, this one we can simplify this. So h is equal to 12 divided by 4, which is equal to 3. So the h is 3 units. This means the x coordinate of the point P will be 3. And now the y coordinate for the point P will be the k. As point P is one of the points lines on the straight lines y equal to 8 minus 2x, then when we substitute the coordinate 3k into the equations, it will be the points that satisfy these equations. So here the y, we're going to substitute it with the coordinate k, and the x we're going to substitute it with the number 3. So here k is equal to 8 minus 6. Then the value of k is equal to 2. And as for method 2, we're going to use the shoelace formula. So here we know that the coordinate of the origin will be 0, 0. And for the coordinate r, it will be 0, 8. And for the coordinate p, here we just know that the coordinate y will be equal to k. So we need to find what is the x coordinate for the point P. As point P lie on the straight line y equal to 8 minus 2x, to get the x coordinate, we're going to substitute the coordinate y with k. So k equal to 8 minus 2x. So move the negative 2x to the left hand side and k to the right hand side. So 2x is equal to 8 minus k. Then x is equal to 8 minus k over 2. So here we're going to arrange the coordinate anti-clockwise, starting with the point's origin. So 1 over 2, start with origin 0, 0, followed by 8 minus k over 2, and k, then 0, 8, and end with the origin again. So the answer for this is 12. So 1 over 2, then we're going to sum of all products in this direction. So 0 times k, we're going to get 0. And when 8 minus k over 2 times 8, this one you're going to get 32 minus 4k. Then 0 times 0, this one will be 0 as well. Then minus the sum of all products in these directions. So 0 times 8 minus k over 2, this one will be 0. And k times 0, 0 as well. 8 times 0, this one will be 0. So this is equal to 12. So move the 1 over 2 to the right hand side. So what left on the left hand side will be 32 minus 4k equal to 12 times 2, this will be 24. So next we're going to remove the modular signs. So there are two possible answers. One is going to be positive 24, another one will be negative 24. So here 32 minus 4k equal to 24, or 32 minus 4k equal to negative 24. So for the first one, we're going to get negative 4k equal to 24 minus 32, which is negative 8. Then k is equal to negative 8 divided by negative 4, which is equal to positive 2. And the other one will be negative 4k equal to negative 24 minus 32. This is equal to negative 56. So k is equal to negative 56 divided by negative 4, which is equal to positive 14. So here the smallest value of k will be equal to 2. Questions B finds the coordinates of P. So if we are using the method number 1, straight away we're going to get the coordinates of P, which is 3, 2. But if we are using the method number 2 here, to get the x coordinate of the P, we're going to substitute the k equal to 2 into 8 minus k. So 8 minus 2 over 2. This is equal to 6 divided by 2, which is equal to 3. So the coordinate P is equal to 3, 2. Questions number 3. In the diagram on the right, ABCD is a parallelogram with vertices A, B, C, and D. Finds A, the area of triangle ABC. As we know the coordinates of each point, then we can solve this using the shoelace formula. So here we're going to use the anti-clockwise arrangement for the coordinates A, B, C. So the area is equal to 1 over 2, start with the coordinate A, 4, -2, followed by 7, 5, 4, 7, and end with the first coordinate. So this is equal to 1 over 2, then we're going to sum of all products in this direction. So bracket, 4 times 5, this one is positive 20, 7 times 7, this one is positive 49, and 4 times -2, this one is -8. Then minus with the sum of all products in these directions. So bracket, -2 times 7, this one will be -14, 5 times 4, positive 20, 7 times 4, this one is positive 28. So here the answer in the first bracket is equal to 61. Then minus the answer in the second bracket is equal to 34. So 61 minus 34, this is equal to 27. So 1 over 2 times 27, this is equal to 13.5. Questions B. Finds the value of K if the area of the triangle ACD is equal to the area of the triangle ABC. So here the area will be equal to 13.5. So using the shoelace formula, we're going to find the value of K. So here we're going to arrange the coordinates anti-clockwise. Start with the coordinates A. So 1 over 2, 4, -2, followed by 4, 7, K, 0, and end with the first coordinate. This is equal to 13.5. So next, I'm going to move the 1 over 2 to the right hand side. So the sum of all products in these directions will be bracket 4 times 7, this is positive 28, 4 times 0, this is equal to 0, and K times -2, this is going to be negative 2K. Then minus the sum of all products in these directions. So bracket, -2 times 4, this is -8, 7 times K, positive 7K, and 0 times 4, this is equal to 0. So this is equal to 13.5 times 2, which is equal to 27. So next, we're going to get everything out of the brackets. So for the first one, we're going to get 28 minus 2K. So here we're going to get plus 8 and minus 7K. So this is equal to 27. So 28 plus 8, we're going to get 36, and negative 2K minus 7K, this is negative 9K. As here we arrange the coordinate anti-clockwise, then this means the area that we get is going to be a positive 1. So when we remove the modulus signs here, the 36 minus 9K, this is equal to positive 27. So negative 9K, this is equal to 27 minus 36. This is equal to negative 9. So K equal to negative 9 divided by negative 9, then is equal to positive 1. Question C. Finds the coordinates of E if ACBE is a parallelogram. So here will be the positions of the point E to form the parallelogram ACBE. In a parallelogram, the length of the opposite sides are equal. So in the original diagrams, the length BC here will equal to the length AD. Now in ACBE, the BC is parallel to AE. This means the length of AE is the same as the length BC as well. This means the point A here is going to be the midpoint of ED. So in questions B, we already know that the coordinate D will be 1, 0. So here the ratio AD to AE is equal to 1 to 1. So using the formula of the divisor of line segments, so when we sum up the x coordinate for the points D and E, which is x plus 1, and divide it with the total ratio 1 plus 1, this is equal to the x-coordinate of the point A, which is 4. So here, x plus 1 is equal to 4 times 2, which is 8. Then x is equal to 8 minus 1, which is 7. And when we sum up the y-coordinate for the point D and E, which is going to be y plus 0 and divide it with the total ratio 1 plus 1, this is equal to the y-coordinate of the point A, which is negative 2. So y is equal to negative 2 times 2, which is negative 4. Therefore, the coordinate E will be 7, negative 4. Questions D. Finds the area of parallelogram ACBE. In questions A, we already know that's the area of the triangle ABC. This is equal to 13.5. So in ACBE, the AB divides the parallelograms ACBE into two equal parts. So we can say that the area of the ABE is also equal to 13.5. So the area will be 2 times 13.5, which is equal to 27.